we're going to begin analyzing synthesis in a backwards fashion. Analyzing synthesis in a backwards reaction. That's called retrosynthesis. Whoa. So what does that mean? Well, it means we have a new type of arrow. This here is a retrosynthesis arrow. And this is my final product. It's called a target. This is how chemistry is done in research. Brief spiel here. We're always finding new molecules in nature that are potential candidates to treat disease. This is an ongoing process happening every day. And once we find a nice candidate, so say somebody isolates a new sea mollusk. It's a creature that's got a shell around it, okay? And they get a chemical out of there that has they screen it against a certain type of cancer they're having trouble curing. And it looks possibly like a good candidate. But we only have 5 micrograms of this stuff that we ever isolated from that poor little sea mollusk. And you've never seen that sea mollusk anywhere else. Does that mean that chemical will never find its way to drug trials? No. You hand it off to the synthetic organic chemist. You tell them, we analyzed it, we found this structure. We tried 5 micrograms in the screening test. It murdered that cancer. We need 1,000 pounds of this stuff now, so we can start trial. And what are you going to do? You can't say get it from the mollusk. You've got 5 micrograms. You have that target. You got to make it from stuff you have in the lab. So pretend this is a target molecule isolated from some valuable source, and you need to make it. And what do you have in the storeroom? Well, here's what you have in the storeroom. You have alcohols, saturated alcohols of 5 carbons or less, and acetylene. So when you show up on test day and you don't know what acetylene is, you just skip this question. You can't start it. I'm telling you, you better know what acetylene means because those words will be there. So please remind me in the forward synthesis, what does acetylene look like? Or you can give me its UPAC name, and then you've kind of answered the question. Say it again. Ethylene is a double bond. Ethine, I'll take. Ethyline's cute, but they don't call it that. But I like what you said. So just remember, acetylene will be the beginning of your forward synthesis no matter what. I'm putting it there. It's way ahead of where we are right now, but that's acetylene right there. We have to describe this goofy arrow here. That is a retrosynthesis arrow. Means I know, this is a quote, how to make the molecules above from the molecule below, which you have not drawn yet. It's not a reaction, it's the exact opposite of a reaction. Okay? You will be doing a reaction on the molecule below when you do the forward synthesis to make the target. So I'm going to go back to our transalkene that we learned how to make previously. It's on your activity 4. Where did you make a transalkene? Right there. What was it before it was a transalkene? An internal alkyne with all the same carbons. Do you agree? The same number of carbons. Okay. Tell me what to draw here. I just said what to draw there. an alkyne with the same number of carbons. And what position is the alkyne? The exact same position as the alkene. Okay? So here is your alkyne. CH2 goes to a box. 1, 2, 3, 4 with a V. I didn't draw that very well. Oh, wow, that's harsh. CH2 with a box. I just want to draw it nice. 1, 2, 3, 4 with a V. I know how to make this alkene from this internal alkyne. Later on, in part B, you're going to tell me the chemicals that you use. I don't need any chemicals other than the skeleton over here. Now the question is, and we're going to go back to our previous synthesis, what was it before it was this? I'm going to go back. What was this before it was this? It was this terminal alkyne with a minus and the extra carbons here with a halogen. Terminal alkyne with a minus reacted with the extra 2 carbons here with a halogen where you need the bond. So I need to pick one of these C's to be a minus, and there's no right answer. You make an executive decision. Which of those C's do you want to be minus? The top one? Okay, I'll go with that decision. You have to draw a retrosynthesis arrow. Don't invent your own arrows. Don't put a normal arrow there. It's got to be a retrosynthesis arrow. It blocks out like that. Before it was this, it was this. With a minus. And what kind of carbon did it react with? Which carbon did it react with? It reacted with this carbon, but that carbon had to have what on it? We have the carbon with a minus charge. We needed a carbon with a minus charge reacting with what kind of carbon? Carbon with a halogen and then the rest of the carbons that you need. Okay? Here is the carbon with the halogen. Up here. It doesn't have it anymore because the reaction happened. But when it was going to react, it had a halogen. We just want to stick with Br. Everybody use Br all the time. I don't mind. Okay. All right. I got to give you something here. Sorry about that. Can't see that. I forgot to grab something from the test. At the top of this page, I want to point out that on that test from fall 21, this was the second part. And then there was a first part with the target was an aldehyde or a ketone, which is a simpler synthesis, has less steps. But also at the top of the page, there was a useful reaction that I forgot to copy. You need it. Here. Given. I am putting it here for you. Useful chapter 10 reaction. You haven't studied 10 yet, so that's why I have to give it to you. If you have a carbon that goes to a CH2 with an OH, you can make it into a carbon with a CH2 attached to a Br by using these chemicals here. This chemical, sorry. Phosphorus tribromide. That's just something that will be on the page for you, ready for you to use. Now looking at it backwards, what kind of molecules what kind of a molecule was it before it was this? It was this kind of molecule. What kind of molecule is that? Give me the name of a functional group. Primary alcohol. So just from the useful reaction, we know this to be true. I know how to make that molecule from this molecule. And I'm circling it. You know why I'm circling it? It's a saturated alcohol of 5 carbons or less. That means I'm finished with those 5 carbons. I don't have to do any more analysis over there. But this thing is not acetylene or alcohol of 5 carbons. I got to go back to my previous synthesis and ask myself, what was this before it was an anion? And here's your answer. The carbon that was an anion was a terminal alkyne. The carbon that was an anion used to be a terminal alkyne. Draw me the terminal alkyne with a retro arrow over here. Here's the terminal alkyne. And you just draw it like that. You don't have to show me the H. I know there's an H. You didn't put a minus. And now the question is, what was it before it was that terminal alkyne? I'm going back. What was it before it was the terminal alkyne right here? It was 2 pieces, the blue piece and this piece. The carbon with the halogen. I almost called it a leaving group by mistake, but you've never heard that before. But that's what it is. Carbon with a halogen and a C-triple-C minus. Okay. C-triple-C minus plus 5 carbons with a halogen. We're almost finished. This is not acetylene. This is not an alcohol, but you're almost done. 2 more red circles coming. Red circle for acetylene. Do I have to go back to the previous one? Where does the conjugate base of acetylene come from? I gave you the answer. It's an acid-base reaction of acetylene. Where does an alcohol, sorry, I almost gave the answer there by mistake. Where does the CH2 bromine come from? CH2 bromine comes from CH2 alcohol. CH2 bromine comes from CH2 alcohol. 5 carbons, circle it. There's all the carbons circled. The retro is over. Now you're going to do your synthesis. What chemical did you have to add to acetylene to make it into acetylide? I'll draw it like this because that's how it's drawn on the page before, to the left. What chemical will allow that? We've used it 2 times earlier today. I mentioned there was 4 different ways to do it. Yet hydroxide came up a couple times again. It's not one of the ways to do it. What are you going to put? H minus. Now that chemical is going to react with this chemical, but you need to make this chemical first. It comes from this chemical. So draw your alcohol. I'm changing my comments in the way. I'm not editing it. I'm just moving it. Okay, my alcohol needs to become an alkyl bromide with the same number of carbons. What chemical allows that transformation? Please just copy it. It's already given to you. The PBr3. Don't look a gift horse in the mouth. Copy the chemical. Okay. What happens when you mix this C minus with this CBr? What do you get? The terminal alkyne. Here's a way to show, mix them Mix them. I'll use a different color. Orange. We never use orange. Mix them and you get the terminal alkyne depicted to the left. That's what this just says, mix them without using words. Bring them together. That now needs to be made into this. This thing, which is this thing, needs to be made into this thing. Tell me how. Tell me how to make this thing. Terminal alkyne becomes C minus. Terminal alkyne becomes C minus, and I noticed I didn't finish the word acetylene. Shame on me. Acetylene. Same chemical, please. What does this chemical need to react with to make this chemical? What does this chemical need to react with to make this chemical? Well, you already told me you know how to make this from this plus this. That is the answer to the question. You need this chemical. You have not made this chemical. You cannot use this chemical, but you need to have it. So where'd it come from? Alcohol. So why don't you draw the alcohol like over here somewhere and react it with your famous chemical to make it into this chemical, PBr3. That's right. 3 points twice. Come on, man. And then mix together these two dudes here. And what are you going to make when you mix those two together? The target molecule. All right. Target molecule. You can do that. I got something that's better. Oh, I got carried away. Hard to believe it was too thick. Yeah. Copyright infringement, I'm sorry. You know, it's free advertising for them. They would never be upset, right? Okay. You can write target there if you want. I don't mind. Just write the word target. I don't even need to hear target molecule. Target. Okay, this is your head is swimming now. I know that. Your head has to be swimming now. You've never seen anything like this. Okay? But just do as many examples as you can, and they start clicking because yes. I need what's here, and I just want to point out that part B is over here. I cut my boxes off. So everything to the right of that's B. So you need to show me what chemical makes this into this. Part A. Sorry, say it again. I don't need those words. Anionic terminal alkyne. Well, you showed me how this became this over here, right there. The chemicals that are needed are here in the synthesis. This is just the skeleton being broken down. No reagent, no other reactants, okay? Okay, so we got that one. And I'll come and get those from you. But flip this one over for our next activity.